Hey everyone, today we're diving into some super cool experiments you can try at home. We're talking about real wow your friends kind of stuff, the kind of science experiments that make you feel like a magician but with, real magic. It's just because it's science. So grab your safety goggles, just kidding, you won't need those, and let's get started. First up, we're going to make a volcano erupt. Not a real one, obviously, unless you happen to have a dormant volcano in your backyard. For this, you'll need some baking soda, vinegar, and a whole lot of imagination. Picture this. You've built your volcano out of clay, Play-Doh, or even just piled up some dirt in the backyard. You create a little crater at the top, and that's where the magic happens. Pour in a generous amount of baking soda, really pack it in there. Now, here comes the fun part. Get your vinegar ready, and a little food coloring goes a long way if you want a really dramatic eruption. Slowly pour the vinegar into the crater and watch as it reacts with the baking soda, creating a foamy, bubbly explosion. It's like a mini volcano right in your own home. Now, the science behind this is actually pretty cool. Baking soda is a base, while vinegar is an acid. When they mix, they react, creating carbon dioxide gas, which causes all those awesome bubbles. It's like a little chemistry lesson and a whole lot of fun all rolled into one. Ever wanted to be a secret agent? Well, now you can write secret messages that only you and your fellow spies can read. It's easier than you think. All you need is some lemon juice, a paintbrush or cotton swab, and a heat source like a light bulb. Dip your brush into the lemon juice, which will act as our invisible ink, and write your message on a piece of paper. It's like magic. You can't even tell there's anything there. Once it dries, it'll be completely invisible to the naked eye. Now here comes the cool part. To reveal your secret message, simply hold the paper up to a heat source like a light bulb or even an iron. With adult supervision, of course. As the paper heats up, the lemon juice will oxidize and turn brown, making your message magically appear. This works because lemon juice is an organic substance that contains carbon compounds. When heat is applied, these compounds break down and react with the air, causing them to darken. So next time you want to send a secret message, ditch the invisible ink pen and grab a lemon. Get ready to get your hands dirty. Or should I say slimy. We're diving into the wonderful world of homemade slime. This stuff is so much fun to play with, and it's surprisingly easy to make. You'll need some glue, clear or white, your choice baking soda, contact lens solution, make sure it has boric acid in it, and some food coloring if you want to get crazy. Start by pouring your glue into a bowl. A whole bottle works best for a good-sized batch of slime. Next, add a teaspoon of baking soda and mix it in really well. This is where the magic happens. Slowly add your contact lens solution, a little bit at a time, mixing constantly. You'll see the slime start to form right before your eyes. Keep mixing until it pulls away from the sides of the bowl, and then get ready for some serious slime time. You can stretch it, poke it, twist it. The possibilities are endless. The science behind slime is all about polymers. Glue contains a polymer called polyvinyl acetate, which is a long chain of molecules. When you add the boric acid in the contact lens solution, it creates cross-links between the polymer chains, making the glue thicker and more viscous, aka slime. Chapter 4. Rainbow in a glass. This next experiment is like a magic trick, but instead of pulling a rabbit out of a hat, we're creating a rainbow in a glass. It's all about density, and it's a great way to learn about how different liquids interact with each other. You'll need some clear glasses or jars, honey, corn syrup, dish soap, water, vegetable oil, rubbing alcohol, and some food coloring. Start by adding a layer of honey to the bottom of your glass. Then carefully pour in the corn syrup, followed by the dish soap, water, vegetable oil, and rubbing alcohol. Here's the key. Tilt the glass slightly as you pour each layer to prevent them from mixing. Once you've added all the liquids, grab your food coloring and add a drop or two to each layer to make your rainbow really pop. The reason the liquids stay separated is because of their different densities. Denser liquids like honey sink to the bottom, while less dense liquids like rubbing alcohol float on top. It's a simple but impressive experiment that's sure to wow your friends and family. To Chapter 5, Lava Lamp Mania. Remember lava lamps, those groovy, mesmerizing blobs of color floating in a bottle? Well, we're going old school and making our own. This one is surprisingly simple and a whole lot of fun to watch. You'll need a clean glass jar or bottle, some vegetable oil, water, food coloring, and the star of the show, Alka-Seltzer tablets. Fill your jar about 3/4 full with vegetable oil, then add water, leaving about an inch of space at the top. Now, add a few drops of your favorite food coloring. The food coloring will mix with the water, creating colorful blobs at the bottom of the jar. Here comes the exciting part. Break an Alka-Seltzer tablet into a few pieces and drop them into the jar. Watch as the tablet reacts with the water, creating fizzy bubbles that carry the colored water up through the oil, creating a mesmerizing lava lamp effect. The bubbles eventually pop and the colored water sinks back down, only to be carried back up again by more fizzy bubbles. This is all thanks to the reaction between the Alka-Seltzer and the water, which creates carbon dioxide gas. The gas bubbles attach themselves to the colored water droplets, making them less dense than the oil and causing them to rise to the surface. Chapter 6, the Egg-Cellent Bottle Challenge. Ever tried to fit an egg into a bottle? It seems impossible, right? Well, with a little science and some heat, you can make this classic trick work like magic. Just be careful, this one involves fire. So grab an adult to help you out. You'll need a hard-boiled egg, a glass bottle with a neck slightly smaller than the egg, a piece of paper and a lighter or match. Carefully peel your hard-boiled egg and set it aside. Now take your piece of paper and roll it into a tight cone shape. Light the tip of the paper cone and carefully drop it into the bottle. Quickly place the egg over the mouth of the bottle, narrow end down. Watch in amazement as the egg gets sucked into the bottle. So how does this work? The burning paper heats the air inside the bottle, causing it to expand and escape. When the flame goes out, the air inside the bottle cools and contracts, creating a partial vacuum. The higher air pressure outside the bottle then pushes the egg inward, making it appear as if it was sucked in. Chapter 7. The Milky Way of Colors. Get ready for some colorful chaos. This experiment is like a work of art that creates itself right before your eyes. All you need is some milk, dish soap, food coloring, a shallow dish, and some cotton swabs. Pour a thin layer of milk into your dish, just enough to cover the bottom. Then, add a few drops of different colored food coloring to the milk, scattering them around the dish. Now here's where the magic happens. Dip a cotton swab into some dish soap, then touch the swab to the surface of the milk in the center of the dish. Watch as the colors explode outwards, creating mesmerizing patterns and swirls. It's like a miniature Milky Way of colors right in your own kitchen. The science behind this colorful spectacle is all about surface tension. Milk contains fat and proteins, which create a sort of skin on the surface. When you add dish soap, it breaks down the surface tension, causing the milk to move away from the soap. The food coloring gets caught up in this movement, creating those beautiful swirls and patterns. Chapter 8, Floating Paperclip Challenge. Can you make a paperclip float on water? It sounds impossible, but with a little help from surface tension, you can defy gravity and win this challenge. You'll need a bowl of water, a paperclip, and a fork, optional. Carefully fill your bowl with water, making sure the surface is as still as possible. Now, gently place the paperclip on the surface of the water. If you do it just right, it should float. If you're having trouble, try using a fork to gently lower the paperclip onto the water surface. The fork helps to distribute the weight of the paperclip more evenly, making it easier to float. The reason this works is because of the cohesive forces between water molecules, which create a sort of skin on the surface called surface tension. This surface tension is strong enough to support the weight of the paperclip, preventing it from sinking. Chapter 9. Blast off with balloon rockets. Next up, we're building rockets. Well, balloon rockets, but still rockets. This is a classic experiment that demonstrates the power of air pressure and Newton's third law of motion. For every action, there is an equal and opposite reaction. You'll need a balloon, a long piece of string, a straw, and some tape. Thread the string through the straw and tie one end of the string to a chair, doorknob, or any other stationary object. Inflate your balloon, but don't tie it off, and hold the end closed with your fingers. Use a piece of tape to secure the straw to the side of the balloon. Now, let go of the balloon and watch it soar across the room. As the air rushes out of the balloon, it creates thrust, propelling the balloon forward. This is the same principle that powers real rockets, only on a much smaller scale. You can experiment with different sized balloons and lengths of string to see how far your rocket can fly. Chapter 10. Crystal Clear Candy Creations. Last but not least, we're making our own rock candy. This is a delicious experiment that teaches you about crystal formation and patience, because these sweet treats take time to grow. You'll need sugar, water, a stove, a pot, jars or glasses, skewers, clothespins, food coloring, optional, and flavorings, optional. First, create a supersaturated sugar solution by dissolving as much sugar as you can in boiling water. While the solution is still hot, carefully pour it into your jars or glasses, leaving about an inch of space at the top. Add a drop or two of food coloring and your favorite flavoring if desired. Now, dip your skewers into the sugar solution, then roll them in some granulated sugar to create a rough surface for the crystals to grow on. Let the skewers dry completely, then carefully lower them into the sugar solution using clothespins to keep them suspended in the center of the jar. Now comes the hard part, waiting. Place your jars in a cool, undisturbed place and watch as the sugar crystals slowly grow on the skewers over the next few days or even weeks. The longer you wait, the bigger your rock candy crystals will be. And there you have it. 10 awesome experiments you can do at home. From erupting volcanoes to floating paper clips, we've covered it all. Remember, science is all around us, and it's a lot more fun than you might think. Thanks for watching. Don't forget to like, subscribe, and let us know which experiment was your favorite. See you next time.